Okay, so let's keep on keeping on. So for this next one, given that sine p equals 3 over 5 and 0 is less than or equal to p is less than or equal to pi by 2, this effectively means that we're in quadrant 1, and that cos q equals negative 5 over 13 and pi by 2 to pi, so this effectively means that we are in quadrant 2. So what we need to do here is we need to find sine p minus q. Now questions like this, oh man, these used to be diploma fodder. You'd see them on the diploma all the time. So I'd recommend you guys pay pretty close attention to what's going on in this question. Starting off, we have that sine p equals 3 over 5. So before I even really attack this question, I'm going to look at what this means. And looking at what this means, if I draw out my triangle right here, I have that sine p equals 3 over 5, and it's in quadrant 1, so our triangle looks like this. Now, from there, if we use Pythagoras' theorem, we get that this is a 3, 4, 5 triangle. Subsequently, with the cos being negative 5 over 13 and in quadrant 2, if I draw out my other triangle, what I'm going to get is I get the negative 5 right there, adjacent over hypotenuse, and then using Pythagoras' theorem, we'll get that that's 12. So that's my p, and that's my q. So looking at sine p minus q, that's going to give us sine p cos q minus cos p sine q. Well, sine p we already know is 3 over 5, and cos q we already know is negative 5 over 13. Now the cos of p is adjacent over hypotenuse on the p, so that's going to give us 4 over 5. And then my sine q is just going to be opposite over hypotenuse, so that one's going to give me 12 over 13. Now from here, I just use my magical power of mathematics, or in your guys' case, most likely a calculator, and that gets me to negative 63 all over 65. So sec of p plus q. Now this one's going to throw you guys for a bit of a spin, because it's sec, but you don't have to worry, because remember that sec is just 1 over cos. So it's just going to be 1 over cos p plus q. And then this is just going to give me 1 over cos p cos q minus sine p sine q. And from here, we make the substitutions. And again, you guys can refer to above to look at them. But that gives me 4 over 5 multiplied by negative 5 over 13. And then that's all going to be minus 3 over 5, all multiplied by 12 over 13. Now, you could also do this by just evaluating what this denominator is and then reciprocating it because of the 1 over. But when we punch this all out, this ends up giving us a solution of negative 65 all over 56. Tan p plus q. Well, for this one, we're going to get the tan p plus tan q all over 1 minus tan p tan q. Now, I'm going to quickly go back up here, and we're going to notice that the tan of p is opposite over hypotenuse, or opposite over adjacent. So that's going to give me 3 over 4, and q is going to give me the negative 12 over 5. So that's just quickly looking back at the triangles right there. We're going to jump down, and then here, what I'm going to get is I'm going to get 3 over 4 all plus negative 12 over 5 all over 1 minus 3 over 4, all multiplied by that negative 12 over 5 again. And then punching this all through, doing everything nice, what we'll end up with is negative 33 over 20, all over 56 over 20, and then having the fraction over the fraction.